Hey there, it's Mr. Tush over at Global, and let's have a conversation about your next project, which is called Rock, Paper, Scissors. And you're going to write an actual functioning win and lose game that you're going to have to play fair and square. Rock, Paper, Scissors is a game you may know, but I'm not going to assume you know. But it's been played for years. And the way this game works is you're going to use J for the rock, K for the paper, and L for the scissors. And if you look at your keyboard, those are right next to each other. And if I type J for rock, I'm going to make my selection here. The game will make a random selection, the computer here, make a random selection, and then tell me if I won or lost. So I'll pick rock, and let me hit the green flag, reset the game, and I'll hit the rock, and there we go. You win. Rock breaks scissors. Now I'll hit the J again. I chose rock, but I lost. Paper covered rock. And each time it's picking a different one. And sometimes I'm tying. Sometimes I'm winning. And sometimes I'm losing. It's truly a randomized game. Well, let's talk about how rock, paper, scissors works first, because I don't want to assume that you know it. And then we'll talk about the kind of logic you have to use. Now, rock, paper, scissors is based on three things, and three icons, and you make them with your hands. You make a fist for a rock, you make a flat hand for a paper, and then you make like a V sound, or like the idiom for cutting that we do with the two fingers to show scissors. And usually it's played between two players, and both choose the icon at the same time. We usually say something like rock, paper, scissors, shoot. Then depending on the choice, you're either going to win, or you're going to lose, or you're going to tie. That's how it's going to come out. And usually if you tie, then you play again until somebody wins. Most commonly this was used on playgrounds and basketball courts to decide who's winning, who's losing, who gets the ball first. Not who's winning and losing, excuse me, who's home and visitor team, who gets to take the ball out first. Something like that is usually how it's decided. And finally, the way the wins and losses are determined are just determined like this. Let's take a look at this. You have paper covering rock, so paper beats rock. You have rock breaking scissors, so rock beats scissors. Then scissors cuts paper, so scissor beats paper. In other words, if you're going to clockwise to your opponent, then you're going to win. If you're going counterclockwise or to the left to your opponent, you lost. If you and your opponent pick the same thing at the same time, then you just play again. It's called a tie. A few examples just to practice this. First of all, we've got a rock and a paper. The winner is the paper, correct. That's because paper covers rock. Scissor and paper. Winner is scissor, that's right, because scissors cut paper. Rock and scissors. Winner is rock, that's right. That's because the rock breaks the scissors. Now, we're going to use a logic called if, then, else. And you'll see that there's if, then statements, just like we've always had here under the control, if, then. But then we've got if, then, else. We're using this kind of a statement here. This is structured a little differently. This has an if, then up here, and then it's got this added else thing here. It's a little different. This is if, then, else. It's kind of like that, but it's got an extra little dongle there. And what that does is it creates a multiple choice situation, but you have to choose. If thus and such exists, do A. If it doesn't exist, do the other thing, B. Makes you choose between A and B. So it works a little like we said before. Like before we had just an if-then. We said if I'm hungry, then I'll eat a snack. And if I'm not hungry, I'm just going to move on. That's the if-then. And if-then else makes me choose between eating a snack and, in this case, I'll say doing my homework. Two options. I can't choose to then go ride my bike in this scenario from a computer sense. Of course, I could make that choice in life, but I'm saying right now that I'm giving myself two choices. If I'm hungry, I will eat a snack. Otherwise, I will do my homework. So when I get home from school, I make the determination if I'm hungry. If the answer is yes, eat a snack. If the answer is no, I do my homework. So I have to pick between two. So in this case, I'm actually going to say, okay, here's my selection, rock. If this is scissors, then I lose. If this is paper, if this is scissors, then I win, excuse me. If I'm rock and this is scissors, I win. If I'm rock and this is paper, I lose. There's another whole thing we're going to put in about how to tie, and we're going to take care of that in the next example. Matter of fact, we are going to write something called pseudocode. I strongly suggest you get some notepaper because this is a really important piece. what's going to happen is you're going to actually begin the if-then with a grand if-then statement. If the computer equals the player, if the computer and the player are the same, then it's a tie. Else, oh, look what I have, my first else statement. Then I'm actually going to stick an if-then inside of it. And that's kind of cool. I'm going to stick it on inside of it. You can pile these things up. And so if the computer and the player are the same, then it's a tie. Else, if the computer is the rock, then I have to make another decision. If the computer is a rock, then if the player is the paper, I win. If the player is not paper, I lose. You think about it, if the computer is rock and I'm the same, we already got tie. If the computer's a rock, then player's paper, I win. If the player's not paper, I lose, because it won't be rock, it will be scissors. This takes care of rock, this takes care of paper. Here's the thing, this is 1/3 of it. It's going to go on and on and on. You're going to have to do this. If they're tied, that's great. If the computer's rock, then I've got to determine whether I win or lose. If the computer's paper, there's another logic for paper winning and losing. And if there's a third one of these that you have to put in for scissors, and if the computer is scissors, if the player is paper, then say you lose. If the player is rock, then you win. So that's how that works. And you have to write this for all 3 possible outcomes, and then you have to program it. So you're going to sit down with a piece of scratch paper. You can use your class notebooks to do this, and then sit down and program it. But don't try to program it without writing it out first. Hope that helps. This is your starter. I will take 1 quick minute and go through the starter. Let's see what it has. So this is your starter. You download this on the class website. And this, when clicked, switch costume to laptop, what's happening is when I click the green, this is actually going to reset everything. This sprite was programmed to do a few things. The stage is programmed for some things. When I click the green, it resets it, and then suddenly rock is set to 0, paper set to 1, scissors is set to 2. Remember, I made them all variables? I actually gave them values. I said, rock, just store the value of 0, and paper, just remember that your value is number 1, and scissors, remember that your value is number 2. Just remember that. And they're just remembering. That's all they're doing. And then over here, this is what's going to react to me. This sprite right here. And I actually just created a sprite, or they created a sprite that said right side keys, J equals rock, blah, blah, blah. Tells the user what to do. And when it uses these when event handlers, when J pressed, when the J is pressed, it sets the player to rock. So it sets the player's value to 0. Switches the costume to rock, so it looks like a rock. And then it broadcasts a message called show pick. Remember this, show pick. And K does the same thing, changes to paper, switches the costume to paper, and then broadcasts show pick. And when L it switches to scissors, switches the costume, and broadcasts show pick. So this whole thing changes the costume for you, and then says show pick. Then you go over to here, and you've got your resets all set up here. And then it says, when I receive show pick, that's the message that it sent here. When I send show pick here, when it gets show pick, it sets the computer. It sets this guy to a random number between 0 and 2. Why the random number between 0 and 2? Because that's what the variables are too. It's going to give me 0, 1, or a 2 at random. I don't know. When it gets show me the pick, it picks a random number on the list. The computer and the rock, if computer equals rock, then switch the costume to rock. Otherwise, if the computer equals paper, then switch the costume to paper. Otherwise, switch it to scissors. And there's the if else and if else, if then else and if then else inside of each other. It's called nesting. So if it's set to rock, give me the rock. Otherwise, if it's paper, then set it to paper. And then I don't need to check if it's scissors, because if it's not rock and it's not paper, it has to be scissors. And then it says broadcast determine winner. And I go over here and I've got a big honkin' blank. That's your job. Your job is, how do I tell the winner, or the player rather, whether they've won or they've lost? And it's going back to this logic right here. I'm going to actually have this pseudocode down here. It says the computer and the player, if computer equals the player, then say it's a tie. I have to actually say if the computer equals the player, something like this, but over here, then I'm going to get all this out of here. I'm going to actually take this out because I'm not going to need it. I'm going to have to redo all this logic inside of this particular equation. That's going to be your job. Hope this helped, and I will do my best to help you in class, but this will take some logic. It will take a full period probably to get this game to work, but that's your job, to sit down and try to make sure that the logic of this, according to this pseudocode times 3, this is the beginning, but there's a bunch of these nested algorithms in this code. It's going to be a big chunk of code right in here. The logic is that it tells the user whether they've lost, or won or lost. And hopefully you'll be able to do it. Best of luck to you, and thanks so much for watching.